A number of the chapters talk about issues around bias, statistics, meta-analysis. So I'll say a few words about what can be found in the handbook in these areas. We have, as James said, a chapter about collecting data, which largely reflects what is in version 5, but there's some new guidance on collecting data from clinical study reports. We've, throughout the handbook, say bits where we can about semi-automation. In this particular area, here's a quote: "At the time of writing, we cannot recommend a specific tool for automating data extraction for routine systematic review production," although I might note that we're slightly more positive about its use in, for example, selecting studies. And we also have a section on dealing with suspicions of misconduct, referring people to the guidance that's in preparation for that. James mentioned we have a dedicated chapter now to effect measures, which is mostly rearrangement of existing material. So, for example, it includes all the material about how to compute effect sizes from data that are not quite in the right format that used to be in the collecting data chapter. So getting standard deviations from p-values when we have continuous outcomes, for example. And we say a little bit more about some of the other effect measures that are increasingly being used, such as a ratio of means as an alternative to a difference in means, or a standardized difference in means, again, when we have continuous outcome data. There's quite a lot of new material on risk of bias, and James showed us how we have chapters 7, 8 and 13 in the core part, and 2 other chapters I'll talk a bit more about later in the further topics. Of course, chapter 8 on the new tool for assessing risk of bias in randomized trials is one of the major developments a lot of people will be noticing in the new handbook. A lot of work has been done over the last 4 or 5 years developing a revised version of the tool, responding to a lot of feedback, criticism, experience, and so on. I imagine many of you will be familiar, but probably not all of you. If you're familiar with the existing version that is implemented in Cochrane reviews, which I'll call ROB1, Risk of Bias 1, it's an outcome-based assessment, and it covers 7 domains of bias. 1, 2, 3, 4, 5, 6 domains of bias. I'm sorry. And on the right, you can see how the Risk of Bias 2 tool, the new one, it very closely maps to the old one in terms of the domains it addresses. It's not an exact matching. We've changed the terminology so that it's hopefully more accessible. It uses more direct language and not jargon. And as you can see in the top row, it's more specific in that it addresses risk of bias in a particular result from a randomized trial. This is because different results, even for the same outcome, different ways of analyzing the data, different scales used to measure the underlying outcome can come with different risks of bias, and we really need to reflect that. I don't expect anyone to read this. This is just to show you what the tool looks like and to highlight some of the key aspects or innovations compared with the last version. Within each of the domains, we have a series of what we call signaling questions, which are reasonably factual questions about what happened in the study, such as, was the allocation sequence random? And the answer options are yes, probably no, probably no, or no information. And we use these questions to guide people, and in fact we've developed algorithms that map responses to these questions to risk of bias judgments for each domain. And the categories of judgment are low risk of bias and high risk of bias as before, but we now have an intermediate chapter of some concerns, which by definition you must have if you're not willing to call it low risk of bias or high risk of bias. We've introduced an overall risk of bias for the result, which is determined again in an algorithmic way as the worst judgment across the individual domains. And a couple of other key innovations are the importance of being very clear to inform an assessment whether we're interested in the effect of assigning people to interventions or the effect of them actually adhering to those interventions. Because issues of non-blinding during the study and related issues of co-interventions, adherence, fidelity to the intervention, implementation of the intervention, the extent to which these introduce bias really depend on whether we're interested in the effect of assigning people or the effect of adhering to the intervention assigned. And lastly, the final domain has changed somewhat, where before we had selective reporting as a kind of amorphous notion. Here we're looking only at selection of the reported result. And so we're only looking at bias in how a result was selective reporting, not bias in results that were not reported, because there is no result to be at bias there. So there's a slightly narrowing of the scope of that domain. So just want to illustrate how that fits in with the wider set of chapters and where we're heading in our longer term strategy. We've introduced a lot of material about thinking through conflicts of interests in trials. And those conflicts of interest will clearly impact on how we consider risk of bias within studies, how we consider risk of bias across studies through publication bias primarily, and how we consider sources of heterogeneity, because people with vested interests may design studies in such a way that makes them different from other studies, perhaps to favour their product over a competitor's. It may not be biased, it may just be designing the trial in a particular way. And we're working on tools to address some of these things. The chapter on conflicts of interests articulates a lot of the thinking that will be behind a forthcoming tool called TACIT, wonderful acronym, Tool for Assessing Conflict of Interest in Trials. The tool for risk of bias within trials, that's ready, ROB2, and we also have one for non-trials, for non-randomized studies, that's ROBINS-I. And we're also, there is work ongoing on a tool that may well be called ROB-ME, although people were laughing at it when we mentioned it in a course last week. Risk of bias due to missing evidence, which would address publication bias and selective non-reporting within trials. So, as I say, the risk of bias within study tools are done, the others we're still waiting for those, but the chapter articulates a lot of the thinking that will be behind those tools when they eventually are finished. And you can see that all of these issues will feed into considerations that are part of the grade framework. So all of these things all these tools will hopefully work very well together, inform each other and lead us from evidence to certainty in the evidence. In the statistical area, our chapter on meta-analysis is not greatly changed. We've expanded our guidance on choosing between fixed and random effects models. We say a bit more about interpreting random effects models, for example, using prediction intervals. A lot of the statisticians have been complaining for years that the methods implemented in RevMan are not the best methods for doing random effects meta-analyses, so we say something about that. There are some things here, of course, that can't be implemented. We can talk about some methods that aren't at the moment implemented in RevMan, although the methods for random effects meta-analyses have been on the implementation list for a while and will get implemented at some stage in the near future. As James said, we have a new chapter on synthesis when we can't do meta-analysis, which is sadly an issue many of us face when doing reviews. So we've introduced some of the options here. Sometimes we can do very simple statistical tests when we don't have the data that we need to compute the size of the effect. We talk about some of the methods that people should avoid, such as vote counting statistical significance. And we provide some guidance on producing structured tables and interesting plots that can convey the evidence in a way that perhaps people don't do as much as they could. And here's one example as a case study in that chapter, where there are an illustration of 4 of the possible plots as an example. So the top 2 are really just plotting the effect size estimates, and which we might do in the sort of situation where we've got some point estimates but no measure of their uncertainty. We might still want to see what they look like. And then on the left, a box and whisker plot may be appropriate if you have lots of data points. The one on the right is plotting the individual data, may be more appropriate when we don't have many studies. The bottom left is something called an albatross plot, and you can plot that based only on having a p-value and a sample size from each study. I won't say more about that, it's an interesting idea. And the one on the right is a harvest plot, which illustrates kind of directionality of effect. And each of these plots can use colors, shading, block sizes to illustrate aspects of the studies that may be related to bias or the particular questions that they're asking. Network meta-analysis is of growing importance in evidence synthesis area. We know from engagement with stakeholders that many of them, particularly at policy level, very much want to be able to select from more interventions than just the 2 we conventionally have been addressing in the meta-analyses in Cochrane reviews. This is one of the most recent Cochrane reviews doing network meta-analyses. They're increasing really quite quickly in number. This one's looking at uterotonic agents for preventing postpartum hemorrhage. And you can see on the left there's a plot of the network. This is how the network meta-analysis gets its name. For each of the blue circles represents one of the interventions of interest that are all eligible and possible interventions for this condition, and the lines between them illustrate where randomized trials have made the comparisons between that particular pair of interventions. So not all pairs have been directly compared, and the network meta-analysis is an approach to synthesize all of these comparisons in one analysis that allows us to compare any one with any other, and importantly allows us to think about which is loosely the best intervention for the particular outcome that we're analyzing. Of course, network meta-analyses may sound like sophisticated things that a lot of people on the webinar may think I'm not going to do one of those. But we also want to stress that a lot of people are setting up data structures applicable to network meta-analysis, potentially without realizing it. So, for example, if we search today on the Cochrane in the Cochrane database for reviews that look at interventions for, so I just searched on that phrase, there are over 800 reviews that are looking at multiple interventions for one condition, and they tend to present multiple pairwise comparisons. And then that's the situation in which thinking about analyzing those more carefully in a more coherent way using the ideas of network meta-analysis will, in some of these situations, I believe, produce more robust evidence.